Hello class, welcome to Unit 3.5A, Finding Slopes of Linear Equations. So when we take a look at slope, slope is most commonly referred to with the letter M. And when we're talking about the slope, we are looking at a lot of times the change in y. So this little delta triangle that you see, that's just referring to a change in y over a change in x. So when we look at those, a lot of times you're looking for the rise over the run. That's what we most commonly look for, especially when you're looking at these graphs down below. The other common formula you'll see with slope is the y2 minus y1 over x2 minus x1. Again, all of these things are just kind of interchangeable when we're saying like the change in y. So the change in y from y 0.2 to 0.1 and over the change in point, x to the second x point. So what we're going to focus on today is just kind of identifying some slopes. So if we're looking for positive slope is anything that's going to be going up and down. So a lot of times you'll see this referred to as increasing. And if we look at a negative slope, this is going to be anything that you see going down. So a lot of times you'll refer to negative slopes as something that is decreasing. When we talk about a zero slope, that means nothing is changing. So this is where you see a horizontal line. And then an undefined, so a lot of time with zero slope, before we get to undefined, a lot of times when you see zero slope, we're just basically saying it's a constant rate of change. And then undefined is going to be when you see the vertical, basically saying it is basically just straight up and down. So those are a couple of things we're looking as we're identifying slopes. Remember, these are things when we talk about looking for positive slopes, increasing, decreasing, constant, and a constant change. These are all things that the slope is kind of talking to. You'll also hear these called rate of change. That's going to be your slope. Once we start putting word problems behind these, a lot of times it is a rate that we are describing. So when we look at example 1, finding slope from a graph, let's try to zoom in here on that first one. What we're looking for is, again, think about those definitions. We are looking for the rise over the run, your change in y over change in x. So when we look at these, when we look at those formulas, change in y over change in x, the first thing we like to look for is how much is it going up. Now, again, it's going to be important that we're finding these 2 points that are directly on one of those intersection points. And then we just go from there. Well, what is the change in y? That looks like that's going up 1. It's running over 2. So our slope is rise of 1, run of 2. And that makes sense, right? Positive answer. We just talked about how a line going up is going to be increasing. It's going to be positive. All those things interrelate. When we look at example 2 here, the rise you can see is going down. So this is where we need to make sure we signify that with a negative 2. And it looks like our run is positive 2. Well, if we look at this, we're going to make sure we say the rise of negative 2 over 2. But this one here, the points we picked, can reduce to just a slope of negative 1. Which also means if we look closely, we could go down 1 over 1, down 1 over 1, down 1 over 1. Okay, let's scroll over to the next example. Here we are with some of those special cases, which looks like in this first case, if you think back, where basically it's a constant change. So basically this is no rise over a constant run. Well, that can simplify to our slope of m equals 0. No change, it's no rise, but it's all run. Whereas over here with the straight up and down, this would end up being a, up and down. You could say it's a rise of 1 over no run. Well, this is where we could say we can never divide a number by 0. So this is where we're going to call this slope undefined. Okay, so that's a look at just finding them from graphs. Okay, take a minute to practice these problems. Pause it now before we kind of go over the answers. Be careful when you count and make sure you're using that -5/4. Talking about rise over run, up 4/1, so m equals 4. Straight up and down, that's our undefined. If we got our horizontal, that is m equals 0. When we look at example 2, finding slope from 2 points, this is where we need to make sure that we are using that formula y2 minus y1, x2 minus x1. So when we're working with example A, a lot of times I like to try to find out like good ways, if they're positive ways to try to subtract these, avoid negatives. But when you look at these, the important part is it helps to say maybe like, let's call this x2, y2, x1, y1. But the order is going to be important. So when we start plugging these in and say, well, what is y2 minus y1? This is where we got to be careful, because we are subtracting a -4. If we can avoid that, we will, but a lot of times you don't really have a choice. In this other one, we're doing a -4 minus a -6. So a lot of this is just going to then be working. So first thing I would do is minus a negative. Remember that always converts to a plus, and minus a negative always converts to a plus. And then it's just a matter of simplifying your answer. So 7 plus 4 is 11. -4 plus 6, or in that case, 6 minus 4. 11 over 2. We want to look to see if there's anything to simplify. In this case, there is nothing that we can reduce. We don't want to change it to an improper fraction. So just leave it. Our slope is 11 over 2. If you look at the second one, again, let's look at these. All right, so all of these look positive. So it doesn't really matter which way we're going to go with them. But again, take a minute, maybe plug in your x2, y2, x1, y1, and then just plug it into our formula. So change in y2 minus y1, and then we got x2, which is 20 minus 9. Okay, nothing to simplify here. So what's 8 minus 16? -8. What's 20 minus 9? That's going to be 11. If we look at that, there is nothing to simplify, nothing to reduce. So our answer is -8 over 11. Okay, continuing through. Once again, if we're looking at these numbers, if we want to call that x2, y2, x1, y1. So if we go with our slope, so we're going to look at a 3 minus 3. Now that looks like that's going to throw up a red flag. We'll talk about it in a second. And if we look at 19 minus 20, okay, there we go. Got them plugged in. Well, now we're going to have a 0 over -1. So if we talk about m equals 0 over 1, that reduces to an m equals 0. So this right here is basically going to tell us that this is going to be a horizontal line with a slope of 0. If we look at this last example, again, x2, y2, x1, y1. What we're going to be looking at, plug those in. So now we got a -13 minus 8, 17 minus 17. So now we have, what, -21 over 0. Well, if we try to divide anything by 0, even try to plug that in your calculator, that's going to tell you some error or undefined. So when we look at this, this is basically going to tell us that this is undefined, and this is going to be some vertical line. All right, those are your examples for 2 points. Let's do some practice. Okay, pause your thing before we go and check our work. Take a minute to check these. Make sure you got the right answers. Now, the only thing is, if you chose maybe to do these problems in the reverse order, so like if I did 0 minus 15, if you chose to do the negative 15 minus 0 and then the negative 11 minus 3, now something like that will end up with a negative 15 over negative 14. But we don't like that double negative, so make sure that that would eventually come back to our same answers you had. This works for all of the problems. If you did the reverse order of your y2s and your x2s and y1s, x1s. But the key here is we should always end up with these 4 answers. Okay, let's look at one more example from some tables. Okay, so when we look at finding slopes from tables, there's 2 ways to go about these. We can just continue with our y2 minus y1 over x2 minus x1, and just pick 2 points. Now, if we're looking at something like this and we see these negatives, I would maybe try to avoid those ones up there and either go with maybe like these 2 in the middle, where we can call that like y2, x2, and x1, y1. And if we plug them in and say 9 minus 7 over 1 minus 0, what we're going to see is 2 over 1, so our slope is 2. Sometimes it's going to be, as an alternative, you may be able to look into your graph. Now, you're going to have to be careful here. When you go from spot to spot, we can see that that's a change in 2. Remember, slope is change in y over change in x. So if we look at there and what's here, now with those negatives, that's still increasing by 1. Negative 2 plus 1 gives you a negative 1. Now, that pattern should hold true for each one. All of these are changing by 2. Now, that's only going to work if all of these, which they are, changing by 1. Tomorrow, what we'll look at is some of them that change by different stuff. But again, if you're looking at change in y, which we just said was 2, over change in x, which was 1, again, our slope is 2. So let's just kind of look at that from the next example. If we are looking at some of these problems, it looks like talking about change in y. Well, that looks like that is going down 3. Now, some of these are a little bit trickier to see, but we are looking at minus 3, minus 3, minus 3. Now, these on your change in y should stay consistent as long as our change in x is consistent. So negative 3 to negative 2, that is a plus 1. That's another plus 1, negative 1. All of these are plus 1. So if you're just looking at change in y over change in x, we could just say our answer is negative 3 over 1. So our slope must be negative 3. Now, again, if you're just having a little trouble with that, take 2 of your points, and if we want to go, maybe down here to those and plug them into your y2 minus y1. Now, I'm just going to go that one right above it. And then we're looking at the 1 minus 0. Again, once we do that little calculation, negative 7 plus 4, that's a negative 3, and over 1, again, proving our way that m equals negative 3. All right, so just pause here and take a look at these last 2 and solve them before you resume and check your work. Okay, so I just chose to look at the tables and found that that first one is a change of 4, plus 4 on all of those, and x is a change of 1. So change in y over change in x, m equals 4. And in example D, it looks like those are decreasing by 5 for your y's and continuing to increase by 1 for your x. So negative 5 over 1 is a slope of negative 5. Tomorrow we'll look at a couple of these where the numbers may not be as consistent, but we can use the same mentality, whether we look at the just change in y from change in x, or if we just go back to our formula with the y2 minus y1 over x2 minus x1, both will get us a satisfactory answer. So at this point, today's lesson is good. Make sure you're catching up with all of your work and keeping things up to date. Have a great day.